Over here, I'm going to do something similar. This would be the magnitude or the amplitude of the current for the resistor. So I use the capital letter. I sub R is equal to epsilon naught over R. Doing a similar type function there, I have epsilon naught is equal to the current across the resistor times the resistance. What is this?
Ohm's law.
Yes. So Ohm's law applies to the amplitudes. So this is just Ohm's law. And so we come up with an equivalent over here that this 1 over omega c we are going to call the capacitive reactance. Capacitive reactance. And so onto my list of rules here. I have a capacitive reactance is equal to 1 over omega, the angular frequency, times the capacity, the capacitance. Voltage across, the amplitude of the voltage across the capacitor is equal to I sub c, x sub c. And the voltage across, the amplitude of the voltage across the resistor is equal to the current across the, amplitude of the current across the resistor times the resistance. All right, questions to here? One more major vocabulary word coming up. It's about to erase this. So now if I take my AC power supply and I connect to it a resistor and a capacitor in series. This is the RC series circuit. What I want to do is let's sort of explore it, find out what we can do. We'll use the phasors. Now, there are going to be 6 phasors that I can draw on this diagram. I have a current and voltage phasor for each of the 3 components. So I start out with, and I recommend that when you draw the first phasor, draw a phasor that is common to as many things as possible. So what is going to be the same for all 3 of these components that are in series?
Current.
Yes. So I'm going to draw my current phasor. And this would be the current phasor from the power supply, which is also equal to the current from across the resistor, which is the current flowing on and off the capacitor. I now draw my component phasors. I know that for a resistor, the current phasor is in phase with the voltage phasor, so my voltage phasor for the resistor will be smack dab on it. That is the voltage for the resistor. I know for a capacitor, the current leads the voltage by pi over 2. Well, there's my current for the capacitor, so my voltage phasor, that's a 90-degree angle there, that is the voltage phasor for the capacitor. And again, these are all sort of arrows that are spinning around in a counterclockwise direction. I also know that Kirchhoff's rules apply. So the voltage I gain across here would be the same voltage as if I went across there, if I went from the bottom to the top. And so my voltage phasor for my power supply has got to be the sum of those 2 phasors. And I'm going to just add them. the voltage phasor for power supply is right there. So it's just right triangle, it's a Pythagorean theorem there. So my epsilon naught squared is equal to VR squared plus VC squared. Now, this is not a universal equation. This is true for this setup. I know epsilon sub naught is, well, I'll do the right hand first. That is going to be the current across the resistor times the resistance squared, plus the current across the capacitor times the capacitive reactance squared. And it would sure be nice if I had some Ohm's law analog for the power supply, and we're in luck. This is the current out of the power supply plus the impedance squared. So if I drop back one, we have voltage from the power supply is equal to the current from the power supply times the impedance. That might be an A there. Impedance. And it is pronounced impedance, it is not pronounced impedance. Not that I'm overly sensitive about it. So now, a lot of these problems you're trying to find impedance. So what I'm going to do is I'm going to, well, that's IPS squared, Z squared is equal to IR squared, R squared plus IC squared, XC squared. That's a C. My currents are all the same, so my currents would cancel out. And I'm left with the impedance for this RC series AC circuit. Z is equal to the square root of R squared plus X sub C squared. Or Z is equal to the square root of big R squared plus 1 over omega C squared.
Did the XC have a name?
The X sub C is, that's capacitive reactance.
Okay.
Do Z and X sub C have units or no?
Yes, they would have units. Remember that the units of voltage are volts. I know that volts is an ampere ohm. Well, here I've got an ampere times something, and it's got to be volts. The product has to be volts, so the units of impedance, the units of reactance, the units of resistance are all ohms. So therefore, since 1 over omega C, the units of that have to be ohms. What are the units of angular frequency?
Radians per second.
Units of capacitance?
Farads.
So an ohm, therefore, is a second per farad. So you get one more unit of time. A second is an ohm farad. Or a farad is a millisecond. Fun with units. So in the lab on Monday, you'll have just an R circuit, then you'll have just a C circuit, and then you'll do an RC circuit. So that should be enough, at least for some of this stuff to look familiar when we get on Monday. Wednesday, we'll wrap up AC, or at least bring in inductors. And then the following Monday, we're going to do another AC lab so that, well, one, I find it an interesting lab, but also so that we will Monday will be the last one, I think, where we will not have covered the material fully before we actually get into it, to the lab. I want to leave on a, well, I want to throw in another note. Some textbooks will give you a formula for the impedance. If they do that, there's got to be some words attached to it because the impedance formulas are specific to the configuration of the setup. This is stuff that's going to be true. I do not have a formula for the impedance written down here because it changes from situation to situation. So, on a quiz or test, please don't get desperate and start looking for a formula for the impedance and going, oh, this will apply. Please know that it doesn't, any formula for impedance applies only to that specific situation. And on that happy note, hope you have a wonderful weekend. Chris, if you have a moment.